Good morning, everyone. Today we're going to talk about the water cycle and how we use and reuse water every day. So let's get started. Here's a general picture of how water flows through our earth every day. It works as an endless cycle. So as you can see, it'll start by precipitation, and it goes through the cycle and continues over and over. Okay, there are four major components to the cycle. We'll go more into detail these later, but you can go ahead and write these down so you can start getting familiar with them. We have evaporation, and transpiration is about the same thing, so you can link those together. Condensation, precipitation, and runoff. Alright, if we think about how much water we have on our Earth, altogether, it would be 100%. Now, if we break it up, we only have 3% of that is fresh water. 3%. Out of that 3%, only about 35% is usable. The other 68% or so is stored in ice caps and glaciers, which is solid, so we can't, till it melts, we can't use it. And from that 30%, only 0.3% of that is surface water. So that's the water that we can see in our lakes and rivers and streams and things like that. So that's just kind of a basic picture of how much water that is fresh out of our total quantity. Okay, water can be found in three different states. It can be found in a liquid state, a gas state, or a solid. It can change between states when it heats up or cools down. So when it heats up, the molecules of the water expand and they start moving around faster and faster, and that's when it turns into a gas, and also known as fog. When it cools down, the molecules condense together and solidify, so that's when it becomes like ice. And this phenomenon explains how the water moves throughout our cycle. Okay, so let's start off with evaporation. So I have a question. Why do puddles disappear on hot days? You know, what is happening when you see a puddle and then after a couple hours you come back to it and it's gone? Well, the water is turning from a liquid to a gas. That's kind of what I was explaining. It heats up and the molecules expand and turns into a gas and rises into the atmosphere. Transpiration is the same concept, except the water turns into a gas right directly off of the leaves of plants. So the plants in our atmosphere soak up water through their roots, goes through the plant to make their food, and then escapes the plant through their leaves. And right from their leaves, it will heat up and then turn into a gas and evaporate, or transpiration, into the atmosphere. 80% of the water that evaporates comes from our oceans. So as you can see in these two pictures, you can actually see the cloud of fog that is rising above our water. Here, this is not above water, but you get the idea of what is happening during the process of evaporation. Okay, so after the water evaporates and rises into our atmosphere, what happens next? Well, we have a process of condensation that occurs. So condensation is when the temperature of the air around the water becomes cooler and changes the water from a gas to a liquid. So when it cools, the molecules condense and turns back into a liquid. Water droplets are not formed, however, until they collide with a dust particle that's present in the atmosphere. So when it rises, the water cools, and then collides with the dust particle to form water droplets. Here's a picture of clouds, and clouds are actually made up of billions and billions of water droplets. Okay, so the water cannot stay in clouds forever. They eventually have to come down. So how does this happen? Well, the water is initially not heavy enough to fall. It's being held up by updrafts of wind and different air masses, and the droplets are not big enough or heavy enough in size to fall. So what happens is the droplets collide and grow in size and weight. And until those droplets are large enough and heavy enough that they override the updraft, then they will fall. This process is known as precipitation. Precipitation is what we experience every day, especially in Michigan. We have different types such as snow, rain, hail, and sleet, and those are just some of them that we're most familiar with. Here are some pictures of different types of precipitation. We have rain, hail, snow, and hail can even get up to size of golf balls. The more collisions that happen and the colder it gets, the larger in size they become. Okay, so once the water hits the ground, it has a few options. One is it can soak into the soil. Another option, it can enter a stream or a lake. And a third option is it could even soak deeper into the soil and recharge our underground aquifers. These are basically just gaps in the ground where fresh water builds up, and we can eventually use this water, pump it out, and use it for our daily lives. That brings me to my next point, is how do we use the groundwater? Well, we pump it out of the wells. We can also create dams and channel waters into different aquifers that is more accessible. And we basically put it into a water system that makes it easier to distribute our fresh water to everyone for daily use. Okay, majority of the water movement and the flow of like streams and rivers comes from the melting of snow caps. Snow caps on the top of mountains actually act as a storage place for water. So they're natural reservoirs, which is another word for storage, and they are stored at the top of the mountains, and until they melt, well, they will melt and then go into our different lakes and streams. Okay, well, finally, we need water to survive every day, so use it efficiently, and from this point on, the cycle will just start over and continue to repeat itself over and over. So thank you everyone for watching the video. I hope you all learned something new. Go H2O. Thanks.